So today we will talk about quicksort. This will be explained through a PPT. Quicksort. Points that will be covered in the following PPT are working of quicksort using recursion for subparts, quicksort algorithm, complexity, and its applications. What is quicksort? How do we define it? Quicksort is a famous sorting algorithm which sorts the given data items in an ascending order. It uses the idea of divide and conquer approach. The array is first split into subarrays, and these subarrays are recursively called to sort the elements. Thus, it follows the recursive algorithm method. How actually quicksort works? First, a pivot element is chosen from the array. You can choose any element from the array of the pivot element. Here, we have taken the rightmost part as the pivot element. Either you can choose leftmost or the rightmost part. The elements which are smaller than the pivot element are put on the left side, and the elements which are greater than the pivot elements are on the right side. Here in this figure, as the pivot element is 2, the smaller elements 1 and 0 are on the left side, and hence the numbers which are greater than 2 are on the right side. This figure actually explains the comparison of pivot element with other elements. The first figure is taken into consideration now. 2 is the pivot element where the pointer is. So a pointer is fixed at the pivot element. The pivot element is compared with the elements from the first index, that is 8. If the element greater than the pivot element is reached, a second pointer is set at that element. Therefore, 8 is greater than 2, so the second pointer would be set at 8. Therefore, this is figure 2 now. Now, the pivot element is compared with other elements, that is 8 is compared with 7, that is third pointer. If an element smaller than the pivot element is reached, that is, if a number which is smaller than 2 is reached, the smaller element is swapped with the greater element found earlier. That is, the element which is smaller will be swapped with each other. The process goes on until the second last element is reached. Finally, the pivot element is swapped with the second pointer. That is, you can see here, the second pointer is relieved. That is, you are checking 8, 7, and then 6, then 1, then 0, 9, 2. Then 1 is smaller than 8, so 1 is swapped with 8. Swapping takes place. Now, the left and right subparts of this pivot elements are taken for further processing in the steps below. You can see the steps are being followed here. Pivot elements are again chosen for the left and right subparts separately. Within these subparts, the pivot elements are placed at the right position. Then step 2 is repeated. Here, the pivot element was 2 and the leftmost part was 0 and 1. So 0 and 1 is here, 1 is here, and 8, 9, 7, 6 is here. So 6 would be considered as it is smaller and it would be in ascending order. So 6 at first, then 7, 9, 8. 9 and 8 we have considered, then 8 and 9. So 7 and 9 is here. The major steps which are followed for quicksorting step method is select pivot element of each half and put at the correct place using recursion method. The subparts are again divided into smaller subparts until each subpart is formed of a single element. At this point, the array is already sorted. Now, quicksort uses a recursion for sorting the subparts. This method is done by using 3 parts majorly, that is divide, conquer, and combine. In divide, the array is divided into subparts, taking pivot as the partitioning point. That is, we use divide, that is the elements smaller than the pivot element are placed to the left of the pivot and the elements greater than the pivot are taken place to the right. Now in conquer, the left and the right subparts are again partitioned by selecting pivot elements for them. That is, this can be achieved by recursively passing the subparts into the algorithm. That is recursive algorithm. Now we combine. This step does not play a significant role in quicksort. It has a little use. The array is already sorted at the end of the conquer step. So there are majorly 2 steps, that is divide and conquer. So this is divide and conquer approach only. Now, this figure explains sorting the elements on the left of pivot using recursion. That is, 2 is the pivot element and we are using the left. That is, 2 is now the pivot element 1 and 0 are the left, 8, 7, 9, 6 respectively are the right. So 1 and 0 will be selected, 0 and 1 in the ascending order, and 1. And these two figures represent the positioning of elements after each call of the partition algorithm. That is 1, 0. So when it takes place in ascending order, it's 0 and 1 here. This figure explains the sorting of the elements of the right pivot using recursion. 2 is the pivot element, 8, 7, 9, 6 represents the right elements. 8, 7, 9, 6. 6 is smaller, so it ascending order. 6, 7, 9, 8. 9 and 8 is checking. 8 is smaller, so it will be first. The position of the elements for each of the partitioning algorithm represents this 0, 1, 2, then 6, then 6, 7, 8, and 9 respectively. Quicksort algorithm. Quicksort algorithm can be explained by the following ways. First, you take array leftmost index and the rightmost index. If leftmost index is less than rightmost index, then the pivot index considers partitioning as array leftmost index and rightmost index. The quicksort will be then added to the +1 of the pivot index, as we can see in the earlier images and the earlier explanations. Partition of array leftmost index and rightmost index. Now we have to use the rightmost index as the pivot index, as we have chosen 2, which is at the rightmost index. Store index would be now leftmost index -1, that is 0 was chosen, so we have to consider earlier, so that is ascending order. And if I, the leftmost index, will be +1 to the rightmost index. Now if element I, which is less than the pivot element, what was the pivot element? The pivot element was 2. So we have to swap the element I with the store element, store index. Now the store index would be ++, which is explained here. And now we have to solve the pivot element, the index one. So we have to return it. This explains the program to write quicksort in C++. These are the header files and using namespace std. This I'm using as function to swap position of elements. That is int a, int star a, int star b. You have to use a temporary variable. Int t is equals to star a is equals to star b, then star b, that is the pointer b, is now the temporary variable. Void print array int array in size. This is the function to print the elements in the array of an array. Int I, and now we are using the for loop, that is for I is equals to 0. If I is less than size, then we have to increment I++, that is it will print array of I, and leave a line, that is enter. Now int partition int array int low and int high. This is the function for the partition of the array on the basis of pivot element. That is pivot element was chosen as 2, so we have to use the partition here. Now int pivot is equals to array of high. That is, we are choosing the pivot element here. In the example, I've chosen 2 as the pivot element. So here array of high. Int I is equals to low -1. The value would be now incremented to -1. Now put the elements smaller than the pivot on the left. That is 0 and 1 were the small elements, so they were on the left hand side, and the greater were on the right hand side. For that, I'm using here for loop, that is int j is equals to low, that is low element. J will be less than high element, and j will be incremented as such for it. If array of j is less than equals to pivot, that is if the jth element is less than 2, the pivot is 2. So I will be incremented, and we have to swap the value of I with the j. Now print array now. This is for backslash and is for the for leave a line, and then we have to swap the values for the according to it. That is I+1, the ith +1 element with the I high part. Now void quicksort, this function will represent if low is less than high. Select the pivot position and put all the elements smaller than the pivot on the left and higher on the right. That is, I've used pi, that is partition arrow low and high. Now sort the elements on the left of the pivot, that is quicksort, using array low pi -1, and right of the pivot, that is pi +1 now and high. These two are the most important things in the program. Now this is the driver main code, that is int main. I'm using the example 8761092 as in the PPT. So int n now will be equal size of data divided by size of data of 0, that is quicksort data 0 and 9 -1, and we have to print the sorted array in ascending order. So this was the explanation of the code written in C++ for quicksort. Quicksort complexity. The worst case complexity would be which is represented by big O, that is O of n square. It occurs when the pivot element picked is either the greatest or the smallest element. This condition leads to the case in which the pivot element lies in an extreme end of the sorted array. That is, one subarray is always empty and the another subarray is n minus 1 elements. That is, maximum is n, so it will be 1 less than it. Thus, quicksort is also called on this subarray. However, the quicksort algorithm has better performance for scattered points. Therefore, quicksort is generally it's efficient when the points are scattered. Now, the best case complexity, which is represented by big omega, is n log n. It occurs when the pivot element is always the middle element or near to the middle element. This is because either we choose a left or the rightmost index, and if the pivot index is the middle element, it would be the best case. Now, average case is big theta representation, and its complexity is n log n. That is same as best case. It occurs when the above conditions do not occur. Space complexity and its application. The space complexity for quicksort is log n. Quicksort's applications is implemented when the programming language is good for recursion, its time complexity matters, and the space complexity matters. Thank you. I hope you enjoyed the video.